How's it going, Precalc kids? Today we're looking at 6-4 polar coordinates. Brr, they're cold. Polar bear, Polaris. Alright. Here's the noteworthy parts right here. Polar coordinate system. You have a polar axis. Okay. Each point is given by an angle. It's given by an angle and a length. Okay. The angle and length will get you anywhere you need to go. Okay. Length. We're going to call this R. Oh, here it is. Your length, then your angle. Okay. Angle, length. Length, angle. First number is the length. Second number is your angle. Okay. Let's draw some of these. Let's plot the points with the given polar coordinates. So first we're always going to start off with our pole. Okay. Now we go up pi over 3 degrees, or radians. Draw a line in, put a dot, we say it's 2. Okay. Next one. We start with our pole. We make our angle about 3 pi over 4. But wait a second, we go -1. Okay. As opposed to +1. So we're down there. Next one, we draw our pole. We go -45 degrees. Drawing a line, put a point, and we say that distance is 3. Negative, remember, is clockwise. Positive is counterclockwise. Okay? I just realized I did not put the camera on, and I've been doing a whole bunch of hand gestures for nothing. You guys will survive. Whoa, what's all this stuff? Just so you know, this is the noteworthy portion right here. If you add 2 pi n to your angle, and it's in radians, that's fine, because guess what? Guess what? Guess what? It's the same thing. Okay? What basically is telling you to do is go into, okay, so let's say that's 45 degrees. 45 plus 360 gets you here. The same spot. Okay, so it's the same thing. 2 ways of getting to the same spot. Just one, you take a full revolution around, and then you get there. The other one's more straight to the place. This is where the nitty-gritty comes. This is definitely noteworthy. If you're given polar coordinates of a radius and an angle theta, then you can find your rectangular coordinates x and y by using these formulas. Or, if you're given x and y coordinates and you would want to get your polar coordinates, use these 2 formulas. Okay? Any questions? Let's just do some examples. We're going to do 4 examples, 1 of each type. Example 1. Find the rectangular coordinates of the point with polar coordinates 2 and 7 pi, 6. Well, your x is equal to r times your cosine of theta. And this one, your r is 2. Your theta is 7 pi over 6. Okay? And 2 times cosine of 7 pi divided by 6 is about 2. Okay? Remember, cosine goes with your x, sine with your y. So y equals r times sine of theta. Your r is 2. Your theta is 7 pi over 6. Okay? And this is about -1. Okay? And actually, this is -1.73. I was in degrees, guys. You can all yell at me if you want. But anyway, your xy coordinate is -1.73, comma -1. Okay? That's all there is to it. You guys want to try another one? Suppose you're given the rectangular form or formula 1, comma -1, and you want to find your polar pairs. Okay. First, what you got to think about is which one of the two formulas are we going to use? When actually we have to use both. To find r, we set up our r squared equals x squared plus y squared. Our x is 1, y is -1. So we get 2. So r squared is 2. So r equals plus or minus the square root of 2. Find two polar coordinates, so that plus minus would probably be helpful. The other thing we set up is tan of theta equals your y over x. Right? Let's check and make sure. Yep. Rise over run, which equals -1 over 1. So then we tan inverse both sides. And the tan inverse of -1 is, well, theta is -785 point. No, it's negative. It's square root of 2 over 2. Okay? Now let's remember that for good old unit circle. Okay. So one of my solutions is square root 2. Not negative pi over 4 would be my solution. Negative pi over 4, or you could have put -0.7885 or 85. You could have also used, negative square root 2, comma. Add that to 2 pi. So you get 7 pi over 4. So, I just added 2 pi to it. So I can add as many 2 pi's as I want. Could add another 2 pi and make it 15 pi over 4. It doesn't matter. Convert this graph to rectangular form and identify the graph. Okay. We can do this. So what we have to do is move that cosecant over. Okay, so we set up r equals -2 over sine of theta. So r times sine of theta equals -2. Just multiply both sides by sine of theta. R times sine of theta is y. How do I know this? Because it's on your notes. So y equals -2. So that is a horizontal line at -2. Okay? And last one, but the doozy. Convert this to polar form. Okay. First, we expand. Guys, all 4 of these examples are noteworthy. If you do not take them as notes, I will not give you full credit. Okay, x minus 2 squared expands into x squared minus 4x plus 2. I'm not going to spend a lot of time on that. Okay? I'm not trying to be a jerk. I'm just saying we're almost through Precalc. Plus y minus 3 squared is y squared minus 6x y plus 9. Just foiling it out, guys. Equals 13. Okay, let's combine our like terms and subtract our 13 over. Okay, so I get x squared plus y squared minus 4x minus 6y plus 2 plus 9 negative 4, all that minus 2, right? Guys, that should have been 4. And this will be 0. Oh, maybe I should have went through that slowly. So I expand out. Negative 2 times negative 2 is 4. Negative 3 times negative 3 is 9. 13 over here, subtract over, it goes away, right? So now, x plus y goes to r. How do I know that? It's in your notes. So first expand, second substitute. What's x equal to? Well, it's what? 4 times r times cosine or sine of, right? By the way, this was r squared. I even looked at it in the notes. Minus 6 times, well, what's y equal to? R times cosine theta, right? Pulling r out in front. Right? Okay, so either r equals 0, so use our factor property, or r equals 4 sine of theta plus cosine of theta plus 6 cosine of theta. And what I basically did is I solved this equal to 0, right? I solved that, and that's how I got my answer. That's it, guys. Enjoy. We're actually almost on chapter 6.